Welcome back, ladies and gentlemen. Mr. Yurko here, and today we're going to be exploring electric motors. Right? You guys know electric motors; they're all around you. These are important little important gadgets that come in lots of sizes. This is a tiny one that's used in toys. This is a 130 size 130 motor, defined by the frame size. These things are everywhere. You got from the tiny little motors inside your phones that cause them to vibrate, up to giant motors that power cars and trains, and even big ships have electric motors inside them to drive them. An electric motor, in most cases, is very similarly designed. This electric motor you can see has three basic components. We've got the motor frame, which holds everything together. It's just a metal box with magnets inside. You can see inside there are permanent magnets to generate a force to give the next component, the armature, which is comprised of electromagnets, something to push against. So this is the armature, and it has, in this case, three coils that are independent. Each one of those is a separate winding of copper wire. It's just a loop. You take a piece of wire and you wrap it. You start at one end and then you wrap it and wrap it and wrap it and wrap it again, and then come out the other end, and that is the coil of wire. And you send an electrical current through the wire to flow around it and then out the other end, and you wind up turning that section of wire into an electromagnet. So since it's now a magnet that can be turned on and off, it can push against the other magnets that are inside the motor. So inside the motor here you can see these electromagnets, or sorry, permanent magnets. So the electromagnets on the armature push against the permanent magnet in the frame. And then to get the power to the armature, on the cap of the back of the motor, we've got the brushes. These two little brass pieces of metal, they're like a pair of fingers that clasp down on the commutator, which is the round set of plates. If you look closely, there are three of them, and those three plates each connected to two of the windings of the electromotor or electromagnet to pass electricity into those coils, so you get the electromagnets turned on and off. So here you have electricity flows in through these electrical contacts on the back of the case, and then they get into the brushes, which go to the commutator, which cause the motor to spin. Today we're going to go ahead and create a sketch of do a little reverse engineering of the case of this motor. When it's all said and done today, you're going to have a sketch like we have one here, showing your motor from three different viewpoints. So the first thing we need is a sheet of paper to sketch on, and a pencil. We're going to use graph paper to get started, make this easier for us. And we're going to put everything we don't need out of the way for now. Here is our motor frame, and like I said earlier, this is a size 130 motor frame. If you want to purchase one of these from somebody, you just go ahead and do a search for 130 motor frame, and you'll find lots of sellers who will happily sell you a motor that matches this one. Now, they're not all created equal. Inside of them you'll find different armatures and different size and strength armatures and different size and strength of magnets. The more powerful the magnets, the more powerful the armature, the more powerful the motor. This motor frame, let's go ahead and take a look at it. If I look at this by comparing it to my grid on my graph paper, you see it's approximately 3 squares wide and approximately 3 squares tall. Now this thing's pretty darn small, so if I try to draw this actual size, it's going to be really difficult for me to get all the detail that I want. So I'm going to double that. We're going to use a 2:1 scale. A 2:1 scale means that everything on the paper is twice the size it is in the real world. So instead of 3 by 3, I'm going to do 6 by 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's my 6th, and then I'll sketch out that square. And that square is now just representing the basic outline, but I've got there's the bearing for the axle shaft, and there's a housing around that. What's that look like? It sticks out the end, and it's not quite a square, but we'll just draw it as 2 squares on here just for ease. There you go. What other details do we have? Well, there's a round portion separated by an edge. It's a flat portion, round portion, so that meets in an edge. So let's go ahead and sketch a line to represent that on both ends. And might as well include our vents. And there's a notch. Okay. So here we have, that's not bad. Let's round it over. So there's some rounded over components. So let's go ahead and round that over, and round that over, round this over, and round this over. And darken your outlines. So here we have our first view of the motor frame. Taking the time to darken it in, be as neat as you can, makes things easier for us in the long run. So there you go, motor frame. Now from here we're going to go left and right and up and down. Just go to the right, project our measurements. The cool thing about using this drawing style is I don't have to, this saves me a lot of time with my measurements. Because I'm going to project the measurements I created in the first view off to the sides. So if I look in here, I've got, see, flat sides, rounded top, rounded bottom, kind of rectangular, and we have a couple of magnets in there. So let's see. First, how wide is this thing? We're about 2 squares, so let's double that to 4. So, got a flat side to start with, and measure over 4. 1, 2, 3, 4. And this is where the flat section ends, top and bottom. So this is a rounded section, so it's going to go all the way up to here, and curve that out, and curve that out, and there's the top of the bottom of the bottom. So there we go. There we go. Be sure to move your hands around to get the best angle you can for creating neat lines. And go ahead and darken those outlines. There's the outline. Let's see, we've got a hole in the middle. And I can see that bearing inside there as well. There is some thickness to the walls. Let's account for that. Pretty darn thin, but it's still there. I'll have to exaggerate it a little bit. There's the wall thickness. And then we have those magnets in there. Magnet, magnet, and another magnet. And there's your right side. There's your front. Let's go ahead and draw the left side. There's a lot of detail on this thing that's important. Well, this is let's project those measurements again. So there's the height. There's to the edge between the round and the flat. There's to the top of our bearing housing. There's to the center. Bottom of the bearing housing. Edge where the round meets the flat. And the bottom. Remember, we're going 4 blocks wide, so vertical line, and 1, 2, 3, 4. That's round on top and bottom as well, just like the back. Of course, this time I'm not looking inside of it. All we see here is the outline, and then the bearing housing and the hole. So there's your axle hole, and there's the out of the bearing housing. Which is a little bigger than the bearing that's actually shoved inside of it. All right, pretty much everything in there. Let's go ahead and take a look at it from above. Let's rotate that up 90 degrees. And right now we just see a rectangle, pair of notches, and a rectangular extrusion off to the left. So let's take those measurements, let's check them up, just like before. And just like here, we've got 1, 2, 3, 4 thick, so this is thick, 4 thick as well. 1, 2, 3, 4. And this is round, so the size of the bearing housing doesn't change from direction, so it's going to be the same size here, so 2 by 2, and from the center 2 by 2. And there you go. Let's darken that in. Oh, we forgot the notch. So we got a notch. It's on center. So let's see. We're going to go here. There's a notch. And there's another notch just off that center. Now darken. Is that rounded at all? Slightly. It's slightly around here. There you have it. We've just created a sketch 2:1 scale of our 130 motor frame. This is all for this video. The next video, we'll get our calipers out and we're going to measure this and start getting our dimensions.